So I'm from Sheffield Robotics, which is an institute across the two universities in Sheffield. And if you don't know Sheffield, it's 2 hours north of London. And it's the home of the first industrial revolution, I think we can say. Stainless steel was invented in Sheffield. And we're hoping that it's also going to be at the forefront of Industry 4.0. And some of you may have heard of our Advanced Manufacturing Research Centre, which is a collaboration with companies including Rolls-Royce and Boeing. And Boeing has recently decided to build a new factory in Sheffield next door to the Advanced Manufacturing Research Centre in order to take advantage of the cutting-edge research that's happening there, not just in manufacturing materials, but also in robotics and AI. So we have a number of questions we've been asked to address in this session, so I want to say something briefly about several of those. So to start with the question about whether Europe could capitalize on AI, I think what we have to realize is that we're just in the beginning of the commercial and industrial impact of artificial intelligence. And we shouldn't make the mistake to think that artificial intelligence is just machine learning and big data. This is just one aspect of artificial intelligence. I've been working in the field since the 1980s, and the roots of the field go back well beyond that. And there are many, many areas of artificial intelligence which haven't yet begun to be mined for their potential for commercialization. And big data has become something of a gold rush. And I was in the Sierra Nevada recently, which of course is where the original US gold rush happened. And of course the first people to get there were just lifting gold nuggets out of the stream. But within a few years, people were arriving and there was nothing left. So rather than chasing after perhaps a train that has left the station, we should be thinking about those aspects of AI where there is opportunity to capitalize and where people haven't seen or taken the opportunity yet. And of course, Europe and my country, the UK, have been some of the originators of some of the biggest innovations in artificial intelligence. And many of these innovations come from natural science into artificial intelligence. So my own background is psychology and neuroscience, and if you look at the machine learning algorithms of today, they are based on research in psychology and neuroscience that was happening in the 40s and 50s and 60s, and people have reverse engineered those biological systems to discover these new ways of developing computer algorithms. And so there's this path from biology into artificial intelligence, where Europe is particularly strong. And I've been involved in projects across Europe for the last 20 years, and I know that we have a really strong community that can provide these kinds of insights. But the mistake we shouldn't make is to think that the knowledge is already there, that there isn't any more research to do. And the European Commission, in its push towards knowledge transfer, has perhaps shifted too heavily away from basic science. And I've seen in the last few years in Horizon 2020 the loss of funding for basic research in cognitive systems and robotics as the emphasis has been placed on funding of knowledge transfer with industry. And that means that some of the finest laboratories in Europe are no longer funded to do their cutting-edge research to build these new AI technologies that we will capitalize on in the future. So the second question we were asked to think about is how we create a green economy through the digital revolution. And I think one of the things we don't think about enough is the sustainability of our robotics and AI technologies. We heard yesterday about AlphaGo and how AlphaGo was the first computer program to beat a master Go player, Lee Sedol. And AlphaGo did that, but it did that by taking advantage of really brute force computing power. And that computing power comes at a price. My colleague Jose Caloi from the University of Paris estimated that in 10 days, the AlphaGo computers used as much energy as Lee Sedol, the master Go player, would have done in his entire lifetime. And so our modern AI computer systems are hugely energy hungry. Another statistic I heard yesterday is that the blockchain technology, which as we know is also very intensive computationally, is projected to require as much energy as the United States. So these technologies aren't sustainable in terms of their energy usage. We need to think about alternative ways of powering the AI revolution. Another challenge is the raw materials from which we build our robotics and AI systems. So again, my colleague will say, Halloy has estimated that we use 80% of the elements in the periodic table in building these systems. And we use some of the most rare materials that we have on Earth, are critical parts of those. So indium, thallium, lithium, tin, silver, selenium, cadmium. And we are now at peak extraction rates. We're extracting more of these elements from the Earth than we have ever before. And within this century, we will reach peak extraction in terms of the availability of some of these elements. And he estimates that in the 2020s and 2030s, things like lithium and indium, and lithium of course is critical to our battery technologies, that we will reach peak extraction and that we will be running out of the raw materials we need to build our systems. And again, we can look to the natural world and we can look to biological systems which are paragons of sustainability. They have natural cycles of growth, decay, and recycling. And they make use of the most basic elements that we have on the planet: carbon, hydrogen, nitrogen, oxygen, potassium, sodium. And they use these trace elements, but they use them in the same proportions that they exist in the natural world. So with my colleague Paul who will speak later, we've just published a book called Living Machines, which has 65 contributions about the potential to learn from the natural world to take artificial intelligence and robotics to the next level. So I want to say a little bit about question 3, the role of the government in this new productive age. And I think it's actually a role for governments to come together. And a model we can take is the Intergovernmental Panel on Climate Change, which has been so successful, I think, in highlighting the challenge of climate change and in helping us predict what will happen and to understand how man-made CO2 emissions can impact on our climate. Because it said rightly that what we cannot predict, we cannot control. And in climate science, we now are getting better at predicting, and that also means we can control. And we can take the model of the IPCC, and I think we could apply it to other areas and other societal challenges. We can apply it to global health. We can apply it to global wealth inequality. And I could see the benefits of taking what is in fact human-AI collaboration. So the modelers in the IPCC run very large and substantial computer models. I would regard those as a form of AI. If we had those kinds of models of the global economy, we could perhaps come up to new solutions to the problem of wealth inequality. And that takes me on to the next question, which is about how technology will change the geopolitical landscape in this century. And one of the things that has been predicted since, I think, the 1980s and 90s is the impact on the market economy of these kinds of technologies, particularly, and Karl Marx, I think, was the first to predict it. When you take away from people who are at the bottom of the economic pyramid the opportunity to sell their labor, then this undermines the whole market, because the people who were able to sell their labor were then able to buy. They could be consumers, and if they're not able to sell anything, then they can't. They don't have any resource with which to buy anything. And it's increasingly being recognised that the economy needs consumers as much as it needs producers. So one of the answers to this is to think about universal basic income as a way of supporting people when they're between work or if they don't have enough work. We need to make sure that as these opportunities that come with AI and robotics feed through, that the benefits apply to everybody. And I think Europe is playing a leading role in this space, thinking about options. And for example, there was a discussion about a tax on robots. That might not be the solution, but we do need to think creatively about how we share wealth and how we ensure that the benefits of these technologies are for everybody. So finally, on the question of the opportunities of the digital Silk Road, I want to talk about this from the university perspective. My own university in Sheffield has just signed an agreement with Tsinghua, I hope I've said that right, a university in China, and the Future Lab, so that university is one of the top rated in computer science in the world. And the partnership that we hope to have with that university, or that we're beginning to have, I think will involve academic exchange, ideas exchange, collaborative research. We've seen a very large increase in the number of Chinese students who are coming to our university in Sheffield, and that in itself is building cultural ties between our countries. And I think the benefit of academic exchange is only just beginning to happen, and perhaps what we need to do more is for researchers from Sheffield to go over to China to learn from you. So with that, I think I'm finished, and thank you very much.